The solving of trig equations. I guess the most basic one is something like this. Tan theta equals some number. But of course now we're not restricted between 0 and 90 degrees. We usually tell you a range of answers to give it between. In this case, 0 and 360. That's probably the most common one they do because it's one time around the circle. So the first thing we need to do is work out which quadrants we're in. Well, tan's negative, so I must be in the second or the fourth quadrant. Then, what was the acute angle in that quadrant? That's what we want to find. And in order to find the acute angle, I need to make that a positive number. I'll just change the pronumeral so I don't get confused. So tan alpha is 2.3673, works out that acute angle is 67 degrees 6. So now I want to put it all together and solve the problem. And you'll recall that the second and the fourth quadrant, if I was to draw those two triangles in, there they are. So in the second quadrant we get 180 minus the acute angle, and in the fourth quadrant 360 minus the acute angle, and then we work out our two answers. Cos theta equals a half. Again, we're going between 0 and 360. First and fourth quadrants, that's where the acute angles will be. So cos alpha is a half, acute angle is 60, so we have our answers. Cosec equals 4. Well, we don't have a cosec button on the calculator, so the first thing to do is to change it into something we can do. Turn it upside down, sine theta is a quarter. We're talking first or second quadrant this time. Acute angle 14 degrees 29, and putting that all together, there's our two answers. Ooh, now we've got to play around with this a bit. But it's just like any equation. We want to make the pronumeral the subject. Well, because it's involved in the trig, it's the trig ratio we need to make the subject. But other than that, it's exactly the same as solving an equation. So rearranging that, we get sine x is negative a half. Third quadrant and fourth quadrant, acute angle is 30 degrees. We end up with 210 and 330. Ooh, two different trig ratios. We've got sine, we've got cosine. This sort of equation where we've got sine equaling cos. So that's all we've got. Very easily handled, but just dividing everything by cos theta. Because remember that relationship, sine on cos, we can change to tan. And now I've got a basic equation I can solve. So tan's negative, we're in the second or the fourth quadrant. There's the acute angle, putting it all together. 158.12, 338.12. Cos 2 theta. Now later on in extension 1 we'll see some formulas that allow us to simplify that. But at this stage, how do we handle it? Well, before I can find theta, I'm going to have to find 2 theta. Theta's going between 0 and 360, so I have to change what I'm looking for. So I'm looking for answers for 2 theta first. So I've got to go around the circle twice. I'm going to look for answers between 0 and 720. Positive, so I'm in the first and the fourth quadrant. The acute angle, 41.25. But this time it's 2 theta is going to equal 41.25, 318.35, but because I'm going around twice, I add 360 to both of those. I have 4 answers, but that's 2 theta. The original question is find theta. Divide everything by 2, and we get 4 answers for this particular equation. Sec squared plus tan. Now this sort of one, we make use of our trig identities that we saw. Because I can change the sec squared to be 1 plus tan squared. And I've got a quadratic equation. The pronumeral is tan theta rather than x. Does it factorize? Yes, it does. Factorizes nicely. So either tan theta is -2, I can solve that one, or tan theta is 1, I can solve that one as well. The tan theta equals -2, second quadrant and fourth quadrants. Acute angle, and we have our answers. Now let's look at tan theta equals 1. That was one of our exact values, 45 degrees. Don't leave it like that. Don't make the person who's looking at your solution have to go and search for answers. Write a conclusion. I will pull it all together and say, well, that means theta can be all these values. I like to put them in numerical order. I just think that's neater. So 45, 116, 34, 225, 296, 34. Okay, so trig equations. Exercise 6H in our book, but I've also in the handouts done the old Cambridge exercise as well. There's a couple of nice questions in there I thought it'd be good to look at.